Oh, here we go. Did I upload yesterday?
Imagine wanting to run for fun.
Oh, wait, is Mandy is actually running or is she cheering somebody?
I don't think she's running.
Okay. All right, so this is 3.2, section 3.2, Rolle's theorem, and the mean value theorem. All right, so place 2 points anywhere on the coordinate plane. They have the same y values. So let's just put it here and here. All right. We're assuming there's basically a horizontal line connecting them. Connect the 2 points with a continuous function that is also differentiable. So you can do anything weird as long as it's continuous and differentiable. So maybe that's weird. All right. Conclusion. There must be at least 1 point on your function where you can draw a line, tangent line, that is horizontal. Here, there's 1 point there, there's 1 point there, there's 1 point there, there's 1 point there. So there must be, they're saying at least one. All right, at least one. That's Rolle's theorem. That's why it's so short. That's all Rolle's theorem says. All right, so Rolle's theorem requires this. It has to be continuous on the closed interval and differentiable on the open interval. In other words, they don't have to be differentiable at the ends. They just have to be differentiable in between. And f of a must equal f of b. So it has to start and begin in the same spot. Then there is at least one number in that interval so that the derivative is equal to 0. Okay, so that's the three conditions. F is continuous, f is differentiable, and f of a equals f of b. That's the requirement for Rolle's theorem. Okay? All right. So first, we're going to determine if Rolle's theorem applies to this function. Okay? Is it continuous? Well, f is a polynomial, so it's continuous. Now, I'm doing overkill on this. What I mean by that is, generally, you don't have to go through all this. You just say it's continuous, and that's enough. Okay? You just want to acknowledge that that's a requirement for you to apply this theorem. Okay? So like lots of times they'll give you a function and they won't give you the actual algebraic expression. They'll just say somewhere f is continuous. But you still have to say f is continuous. Even though they told you it's continuous, if you don't mention the fact that it's continuous, then you're not acknowledging that it is a requirement for that theorem. Okay, so you need to acknowledge the three conditions. And then f is a polynomial, so it's differentiable. So that's all the conditions for a differentiable. Okay, so it's differentiable on it. So again, they might not give you a function, but they'll just say it's like, here's a very common way they'll say it. A function is twice differentiable. You don't care if it's twice differentiable for this. Once differentiable is enough. Here's something else though. If a function is twice differentiable, it implies continuity and differentiability. Did you understand? I'll say it again. If it's twice differentiable, it implies it's completely continuous, and the first derivative, it means it's differentiable for all numbers, or whatever interval they give you. What I mean by that, the second derivative, if they tell you it's twice differentiable, that means the first derivative has no weird spots, right? Where it doesn't do a corner, or it doesn't do where it has a vertical asymptote, or anything like that. If it's twice differentiable, it excludes all those weird conditions. All right.
Now, is it still differentiable when it has like a corner or?
No. So corners are not differentiable. Vertical tangent lines are not differentiable. Okay, so 2, and then now you're going to check to see if f of a equals f of b. So this is the weird one, and it only applies to Rolle's theorem. So the theorem you're going to use the most is actually the next one, not this one. Okay? But getting in the habit of answering the first two is a good idea because that applies to the next theorem. All right. So this one just is asking f of a equals f of b. So here, a is -2 and b is +2. So a is -2 and b is +2. So we're going to do f of -2, which equals, is my pen dying? F of -2, plug in -2, so it's -2 to the 4th, minus 2 times -2 squared. So it's 16 minus 8. Is that right?
Yeah.
And for positive 2, 2 to the 4th minus 2 times 2 squared. So that's 16 minus 8 again, so it's 8. So f of negative 2 equals f of 2, which equals 8. So this is now acknowledging the third condition, that f of A equals f of B. And you generally want to mention what it's equal to. So that kind of justifies your conclusion, mentioning what it's equal to. All right, now what? Now find the value C. Now find the value C. Right? If the theorem does apply, find the value of C guaranteed by the theorem. So remember what the value is. It's the derivative where it's equal to 0, where the derivative is equal to 0. So you take the derivative. So it's 4x cubed minus 4x. Set that equal to 0 and solve that. Take out a 4x. So you got x equals 0, and this gives you x equals plus or minus 1. This pen is dying. All right, now, which of those points are in the interval? All three of them. All three of those are in the interval.
So does that mean it has 3?
So it has 3 values. But you only needed 1.
So are we supposed to graph that as well?
Looks like you're supposed to, isn't it? Let's not bother. You want to graph it? So what's a good way to graph this? A good way to graph this is actually plotting these critical points. Let's go ahead and do it anyways. All right. So what I'm going to graph, so I'm going to make a little t-chart over here. All right. So I want x, f of x. And I want to plot the endpoints, so negative 2, and then all these points in between. So negative 1, 0, 1, and 2. All right. So if I plug in negative 2, I get what? 8. Right? We did that already. Is there 8 on here? It's way up here. And positive 2 was 8. It's way up here. Negative 1. Plug in negative 1. Remember going to the original function. So we're plugging it into this thing. So that would be what? 1 minus 2 is negative 1. So at negative 1, it's negative 1. So it's way here. And then at 0, it's 0. Plug in 1, you get negative 1. So it looks like this. Okay?
So the endpoints don't have to have a derivative of 0?
Correct.
Okay. I was thinking the endpoints were critical points, but they're not.
No. Okay? Questions? Any other questions? So that's Rolle's theorem. Mean value theorem. So this is the one College Board expects you to know. They will ask this question several times. At least once in free response, and at least once or twice in the multiple choice. Okay? Once in the non-calculated multiple choice, and once in the calculated multiple choice. Okay? So it's 3 questions, but it's not difficult, right? Even though it only appears once, it's not a difficult question, so we should be able to get it. All right, so what does this say? So it starts the same way as Rolle's theorem. It's continuous on the closed interval and differentiable on the open interval. And then there exists a number C, just like the other one, there exists a number C, Rolle's theorem, right? In AB, but this time it's saying that the derivative at some C is equal to the secant, the slope of the secant line. That's what this is. This is the slope of the secant line between the endpoints. Right? So this one only has 2 conditions. So you don't. So this doesn't require this thing. You don't need this. This is not needed. That's only required for Rolle's theorem. Okay. All right. So I'm just going to go straight into an example. So determine the mean value theorem applies to this. Okay. So looking at this, where is this function undefined? Where is this function undefined? X equals 0. Is that in this interval?
No.
So it's okay. So we don't care that it's undefined as 0 because it's not in this interval. Okay? So it's otherwise continuous on this interval, and it's differentiable on this interval, right? Only x equals 0 is a problem, and 0 is not in there. All right. Okay, so so I'm saying so too many times. If f is undefined at x equals 0, but 0 is not in the interval, f is not differentiable. At x equals 0, but 0 is not in the interval. So this is overkill. Okay? So this is me being sure that they understand that I know what requirements are. But if you probably on the test, on the AP test, if you just said it's continuous and differentiable on 1,5, that's enough. Okay? I have noticed that that's been enough. But this says state thoroughly, so I did. All right. If the theorem does apply, find the value of guaranteed C. So that means first you want to find this expression, f of b minus f of a over b minus a. So f of b is, so we're looking at f of 5 minus f of 1 over 5 minus 1. F of 5 will be, so you're plugging in 5 into that expression, so I get 2. And if I plug in 1 into that expression, I get negative 2. So that's plus 2. So that's 1. Do you agree with my math?
Yes. I don't know, Victoria's not here.
No, Victoria, I need Victoria to check my calculus. Not my arithmetic.
Yeah, basic math I got you on.
All right, now we're doing well. So now we want to know when is f prime of c equal to 1. So what's the derivative first? So we've got to take the derivative. The derivative is 5 over x squared. Do you need me to show you how I got that?
Sure.
Okay. So I think the first part's easy. What's the derivative of 3? 0. So that means the question is, what's the derivative of negative 5 over x? So let's just do like a g of x over here. So that's negative 5 over x, same as negative 5 times x to the negative 1. You agree with that? So now you take the derivative power rule, that becomes positive 5, x to the negative 2. X to the negative 2 just goes down there. Okay? Now we want to set that equal to 1. So we want 5 over x squared equal to 1. Alright, so we want the derivative equal to 1, so that means 5 equals x squared. That means x equals plus or minus the square root of 5. Now, the negative square root of 5 is not in the given interval. So you just want x equals square root of 5. Right, that's approximately 2 point something. So you know it's square root of 5. So that's C. So C equals square root of 5. This is the guaranteed C. Okay?
So you said you wouldn't use the negative, so it would only be positive, right?
Right. Because the negative is not in this interval
Mhm.
of 1 to 5. Question on the first example. All right, example 3, when the mean value theorem doesn't apply. Okay, looking at this one. Okay, I'll zoom in on this. When does it not apply? So x to the 2/3, even though this is a radical, the odd roots are okay with negative numbers. So this is okay at negative 1. Right? If you can plug in negative 1, you get positive 1. Don't you? Yeah. You square it, take the cube root, you get 1. Okay? Plug in 3, no problem. So, but the way the question's asked, it implies that this doesn't apply. So that means look at the derivative. So take the derivative. The derivative is 2/3 x to the negative 1/3. Right? If it's a negative exponent, that means it goes downstairs. You get 2 over 3, and it's the cube root of x. So h So h of x is not differentiable at x equals 0. Hence, Rolle's theorem does not apply. Or hence the mean value theorem doesn't apply. All right. So B, this one's easier. This is undefined at x equals -2, and -2 is in that interval. G of x is not continuous at x equals -2. So the mean value theorem does not apply.
You got -2 by.
Setting the denominator equals 0.
Yeah, okay. Just wanted to make sure.
That's fine. All right. Number 4. 2 stationary police cars equipped with radar are 5 miles apart on the highway, as seen in the figure.
That is one long semi-truck.
It's not drawn this way. Although, if you ever go up north, there's some they're like a 10 trailer truck, or not, maybe not 10, but a bunch of trailer trucks.
I think that's called a train.
No. It's on the road. It's on the road.
I think it's on the train.
I agree, but it's on the road. They should have. Never mind. All right, off topic. All right. As a semi-truck passes the first patrol car, its speed is clocked at 55 miles per hour. 4 minutes later, when the truck passes the second patrol car, it's clocked at 50 miles per hour. Prove that the truck did or did not exceed the 55 miles per hour. Okay. So, the velocity is a continuous function. Velocity of a vehicle is a continuous function. How do I know that? Because cars can't teleport. Okay? So you can assume that, so that's my continuous, because vehicles don't teleport. Differentiable, because it's just a continuous function. All right, so that means the mean value theorem applies. So now, so that means, so you look at this, they're what, how many miles apart? They're 5 miles per hour. I'm sorry, 5 miles apart. 5 miles apart. And it took them 4 minutes. Yeah, 5 miles apart, 4 minutes. So what is that in miles per hour? So it's 5 miles in 4 minutes, and we want to convert this to miles per hour. So that means you got to convert the minutes to hours. So that's 60 minutes in 1 hour. Okay, so the units of minutes cancel. So you're going to do 5 times 60 is 300 miles per 4 hours, and that's going to give you like what, 75 something, 70 something, 75 miles per hour. So his average. So this is the slope of the secant line. This is that f of b minus f of a over b minus a part. Do you understand that? This part right here, what I just found, this is equivalent to the f of b minus f of a over b minus a, right? The f of b minus f of a is the miles, b minus a is the minutes, right? The miles per, do you understand that? Okay? So now we're saying that at some point on that interval, he had to be going 75 miles per hour. Okay? So, by the mean value theorem, you have proven that he had to be going 75 at some point. So, the police car sitting there with the radar gun doesn't matter. The only thing that matters is that they can clock how long it took them to travel that 4 minutes.
Travel 5 miles.
Right. I'm sorry, yes. The time it took him to travel the 5 miles. So you can use calculus to give speeding tickets. Now the question is, will that hold up in court? No, because they don't understand math. All right. Hey. Tennessee tried to pass a law that said pi is equal to 3.
Please tell me you're joking.
I am not joking. Well, maybe I am. But someone told me that and I believe them. I am passing on a possible mistruth, although I believe it. I think it was like some legislator, their child was getting bad grades in trig and he wanted to pass a law to fix that grade.
I can see
Wait,
that
so can you
happening.
explain again why that is the f of b minus f of a over b minus a?
Okay,
Because that's 0.
what's 0?
Well, it says on the picture, it says on the left time is 4, and then on the right time is 0.
Right, so
So
that's the
the
4
right-
minus 0.
Yeah, and then the top would be 0 minus. What is
This is the distance between them.
it?
Right, so so it's kind of like saying, this is mile marker 75 and this is mile marker 80. So at t equals 0, he was at 75, at the mile marker 75, and at t equals 4, he was at mile marker 80. So that's the 85 minus the 75. Does that make any sense?